Welcome back, Math 10, to Lesson 5. So in today's lesson, we're going to kind of combine Lesson 4 and Lesson 3 together. So we're going to use our trig laws and help us solve for angles and sides. Okay, so that's essentially what we're doing. To start off, we're going to get right into it with this question here. It says, find the value of x to the nearest whole number. Well, this one right here, x is the angle. So for this one, we're going to say tan x is equal to, well, I look at this, we have opposite over adjacent. My opposite is 12.7, and my adjacent is 5.2. So x is equal to the inverse of tan of 12.7 all over 5.2. So now I'm going to plug that in my calculator. Once again, make sure your mode is in degrees, okay? Plug that into my calculator, and I'm going to go second tan, and I want 12.7 divided by 5.2, and I end up getting 67.7 degrees, which is 68 degrees. Okay, now let's take a look at my next one here. We're knowing the angle, but what we don't know is the side, so x is a side, and it is, in this case, the hypotenuse, because it's opposite to the right angle. And I know the adjacent, don't I? Or sorry, I know my opposite. So if I know the opposite and I want to find the hypotenuse, I'm going to have to go sine. So sine 69 is equal to 126 all over x. So now I'm going to rearrange this. I want x on top, so multiply by x, and divide by sine 69, divided by sine 69. Okay, so I end up getting x is equal to 126 all over sine 69. Now I'm going to plug that into my calculator. Alright, so here we go. I'm going to go 126 divided by bracket, and I have sine 69. So I go sine 69, bracket, enter. And I'm going to get 134. Oh, 135. 134.9 is 135. 135 is my units. Okay? Let's take a look at the next one. I have 24 degrees, and I want to find x. In this case, x is the opposite. Okay? My adjacent is 68. So, we know tan, we're going to use tan because we're looking at opposite and adjacent. Tan 24 is equal to opposite, which is x, all over my adjacent, which is 68. So I have to multiply both sides by 68. 68. So I get 68 tan tangent of 24 is equal to x. So let's write that out. Get 68, and I put tan 24, enter, and I end up getting 30 degrees, or 30 is my answer. So x is equal to 30. Okay? Let's look at my next one here. I have 7.2 and 4.0. And I want to find this angle here. Well, I have hypotenuse and adjacent, so I'm going to have to use cosine. So cos x is equal to opposite, or adjacent, divided by hypotenuse. So 4 divided by 7.2. Okay? Now, x is equal to cos to the inverse, 4 divided by 7.2. Plug that into my calculator. So we're going to end up getting second cos, 4 divided by 7.2, close my brackets, and I end up getting 56 degrees. There we go. My next example says a telephone pole is 11 meters high and is supported by a wire of 13 meters long, fixed on top of the pole to the ground. So we have, I'm going to draw it out first. We have my telephone pole is 11 meters high, and I have a wire that's 13 meters long fixed to the top of the pole, so that's 13 meters, okay? Now it says, calculate to the nearest degree the angle between the wire and the ground. So I want to figure out this angle here. So the wire and the ground, that's going to be my angle of elevation. Alright, well, let's take a look at that. I know my hypotenuse and my opposite. So I'm going to go sine, I'm going to call this angle x, x is equal to, I have here, opposite 11 divided by my hypotenuse, which is 13. So we know then sine x is equal to the inverse of sine 11 over 13. So let's plug that into my calculator. Second sine 11 divided by 13. And I end up getting 58 degrees. Okay? So we know that's 58 degrees. Now, it wants us to calculate how far it is to the nearest 0.1 meters between the point of the ground and here. There's two ways of doing that. I could use the Pythagorean theorem, or I could use my trigonometric ratios. The first one here wants us to use the Pythagorean theorem. So we know c squared is equal to a squared plus b squared. Right? Now, we want to find my a. So a squared is equal to c squared minus b squared. Continue this, I'm going to get 13 squared minus 11 squared, which is going to give me 169 minus 121. Okay? Some more, I'm going to get 48 is a squared. Okay? So we want a is equal to the square root of 48. Alright? Now, if I put this in my calculator, it's going to give me approximately 6.9. Okay? Because 7 times 7 is 49. And that's very close to 49, so I'm saying 6.9. And that is in meters. So let's try it with the trigonometry way. So I'm going to have cos. I'm going to look at cosine here because we're trying to find this. Or I could use tan for this one. I'm going to use cos. So I'm going to say cos. And I have x, which we know is 58, is equal to, we're going to have a, my adjacent, all over hypotenuse, which is 13. I could have used tan 58 and used the 11 and down there, but I'm going to use cosine. Okay? Now, I look at this. I'm going to have to end up going, solve, multiply both by 13, multiply by 13. So I end up getting a is equal to 13 cos 58. Plug that into my calculator, and I'm going to end up getting, again, 6.9 meters. So we get around the same answer. Put that into our calculator. So this last one wants us to solve the following triangles. So when we say solve the following triangles, we want to find out every side and every angle. So let's start with my angles. I want to figure out what angle C is. Well, that's going to be 180 minus 90, because all triangles add to 180, and then I'm going to minus 37. Okay? So if I do that, that's going to end up giving me 53 degrees. Alright, so now I know this is 53. So we're done one. Now I have to figure out this part here. This is side A, and this is side C. Okay? Well, I could do it two ways. I could either use the Pythagorean theorem, or I could use my trig identities. The trig identities is actually a little bit faster, so I'm going to stick with the trig identities for this one. So once again, I'm going to use this 37, and I'm going to use sine, which is opposite over hypotenuse. So sine 37 is equal to opposite, which is my a, over a hypotenuse, which is 33. So I'm going to sine, I'm going to have a is equal to 33 sine 37. Multiply both sides by 33. So let's plug that into my calculator. I plug it in. I'm going to get 33 sine 37 will give me a total of 19.9. Okay? So I'm going to get 19.9, which is, I want to say 20. 20. So A is equal to 20. So that's 20. Now I want to find C. So I'm still going to use that 37 degrees. And for C, what am I going to do? I'm going to use cosine law. Okay, so I'm going to say cos 37 is equal to C all over 33. So now I want to go 33 cos 37. So C is equal to 33 cosine of 37 degrees. So let's plug that in. We're going to go 33 cosine 37, and that's going to give me 26 as my final. Okay? So this is 26. Now let's do my very last triangle here. So let's look at the second one. Okay? We're given two sides, but none of the angles. So start off, if we know two sides, we could find one of the angles. So I'm going to start off with angle D. Okay? So I'm going to use sine, because I know the opposite and the hypotenuse of D. Sine D, angle D, is equal to the opposite, which is 4.9 divided by 53, or 5.3. Okay? So I know D is equal to the inverse of sine of 4.9 divided by 5.3. So let's plug that in. We're going to go 4.9, oh, clear. We're going to go second sine, 4.9 divided by 5.3. Alright, do that. And I'm going to get 67 degrees is D. So D is equal to, well, 68 degrees. We're going to round up. 68 degrees. I'm rounding up to the nearest one. Okay? 6.5, 68. Now, let's take a look at F. Can we find F? So F, I know the adjacent and my hypotenuse. So I'm going to go cosine of F is equal to 4.9 divided by 5.3. So F is equal to the inverse of cosine, 4.9 divided by 5.3. Okay? So let's plug that into my calculator. I'm going to go second cos, and we have 4.9 divided by 5.3. Close my brackets, and I end up getting 22.4. So that's 22 degrees. Now also what I could have done is I could have gone 90 minus 68, which would have given me 22 as well. Okay? Now my last one I'm going to do here is I want to find my angle F, so that little f. So for this one here, for this third side, I could use either trig identities or Pythagorean theorem. Now since I rounded for these angles, I'm actually going to just use my Pythagorean theorem. Okay? So I'm going to go f squared is equal to, now hypotenuse squared, 5.3 squared, and I'm going to subtract 4.9 squared. Okay? So let's take a look at that. I'm going to plug it into my calculator, have 5.3 squared, enter, and then I'm going to subtract 4.9 squared, enter. So now that gives me a total of 4.08, which is equal to 4.08. Okay? That's f squared, side f. Little f is always the sides. Lowercase is normally sides. Big F's, capitals are my angles. Okay? Now I have to square root. So that's going to give me approximately 2.0. So this height here is 2.0 altogether. So now I solved my whole triangle. That's how we do everything. Good luck. See you tomorrow as we work at this together in class.